Hello and welcome to the channel. Today we are starting an exciting series where we build a distributed cache system in Golang from scratch. This is a hands-on step-by-step project, and by the end of the series you'll have a fully functional system that scales. So in this first video we are going to have a series of 3 videos. So the first video will build the cache node and the HTTP endpoints. The second video we will work on the eviction policies. As you know, for a cache, data gets stale and you need to evict, and the eviction policy will depend on your business logic and how warm you need your cache to be and all that. And in the last video in this tutorial we are going to handle replication, and the main thing we are going to use to replicate data across the nodes to ensure that keys are assigned to nodes to minimize redistribution when nodes are added or removed is a consistent hash ring. So this is what we are going to build. If you find such tutorials useful, give them a thumbs up, share with a friend who might benefit from this, and let's create tutorials that are not to-do list and all that, things that we can actually use and implement in real world software and systems. So we will jump into my IDE and we can start. So I've scaffolded the project. So we'll have the cache package, the server package, and our main package. Just to test if our main package compiles, we'll run main.go. And welcome to this tutorial. So we'll minimize this window and also minimize that. I hope it's clear enough. I think I can add the font size. Let me add the font size. I don't know, where do we code editing? No, font. Yeah, so it's 14. I think 14 is good enough. Let's make it 16, and I think the line height also 16. Yeah, I hope it's big enough. So what do we need? First we'll need a structure called item, and it will be a structure with one field, value of type string. So this is what we are going to start with. In the later chapters we can do enhancements so that this value can be an interface. If the value is an interface, it can carry any data any data type. So you can carry any data type and then handle it downstream in your application as you see fit. So next, I think we're going to create the cache type, cache, which is a structure, and our cache is going to contain items. And what will be the type of these items? It will be a map of string, they are the value, and then item. Yeah. The next part, how do we initialize a cache? We will create a function new cache. It will take nothing, but it will return a pointer to cache, and we will will return a reference to and items will make a map of string and item. Oh, these should be items. Yeah, so we'll need two methods to set and get on the cache struct. So C for cache, and then we'll have a method to set. It will take a key and a value of type string, then it will return nothing. So how will we set? We will set the items at the key index to the value. We'll need item, then value, yeah, like that. And then how do we write our get function? It just happened. Yeah, so we'll format that like that, and then we need a function to get C cache and get. What to get will require a key of type string, and then it will return a string and bool. So it will also tell us if what we are getting is there. If it's not there, it will return an empty string. So we'll have item comma found equals to c.items at the key index. If not found, we will return an empty string and false, show that the item is not there. If no, we don't need found, so we'll return item dot value, the value of the item, and true. So yeah, that is our skeleton cache. So what we need next is to add thread safety. So let's name it cache mutex, will be of type sync.RWMutex. So what the read write mutex does is it locks the cache when you're reading and writing, so that we don't corrupt the data, or we don't we wait, so that it's concurrency safe, thread safety, so that when you run this, even if 1 million clients are writing to it, we don't corrupt our data. Yeah, so we'll need that. So when setting, we will call c dot cache mutex dot lock. We lock, and then we defer c dot mutex dot unlock. So what this does is when you're setting, only that process that is setting has access to this. The others wait, and then when it's done, it unlocks, and another can follow. The same thing will happen when we are getting a value. We lock, read, get the value, return. Yeah, so I think that's about it for the skeleton side of this. So improvements that can be done here is create the value to be the value can be of type any, and then we cast it to string. Yeah, here, but I don't want to complicate that. Let's get this working fast. So it will be key value pairs, string value pairs. So our cache needs to interact with the outside world. Cache node needs to interact with the outside world. So we will need some form of communication, and we are going to implement this via HTTP. So we will need a server, and then two handlers to set and to get. So type cache server is a structure, and what do our cache server have? It has a cache of type pointer. It will be a pointer to cache.cache. So we need a function to initialize our cache server. Func new cache server. We'll take nothing for now, and then we'll return a pointer to the cache server. And what will we do here? We will return a reference to cache server, and for the cache we initialize a new cache. Yeah, so let's write the set handlers and all that. So we'll need a type set request. It will be a structure, and our set request, what will our set request have? It will have the key. Wow, why is this misbehaving? It will have the key of type string, and then we annotate it with JSON, and then the value also of type string, and then we annotate JSON. So our first handler will be, let's implement the get handler. Cache server pointer to cache server get handler. Golang handlers don't return anything. So, but they take something. So here we'll take a HTTP response writer and a pointer to HTTP request. So we expect that the get handler will retrieve something from the cache. So the key, we will pass in the key as a query parameter, So let's extract the key from the URL r.url dot query dot get key. We get the key and then we check if the key is in there. We check if a matching key value pair is in our cache, equals to cache server dot cache dot get the key. If not found, what are we going to do if it's not found? We just write http not found, then this will take the response writer in the request, and we return at this point. If it's found, we will encode the value into JSON into the response writer. So JSON dot new encoder. You want to encode into that dot encode we're going to have a map string and value will be the value we found there. Then now the set handler will take this almost similar signature. So let me copy paste this here, and then we'll have the set. So we need to decode error equals to JSON dot new decoder. And what are we decoding? R dot body. We call dot decode into the request. If error not equal to nil, we'll return the HTTP error. Pass in W, the response writer also takes the and then the error value. Then the status. We'll give it a status 400 because we are assuming that it was not in this format. So when everything is good, now we set the key value pair c dot cache dot set right dot key, comma rec dot value, and then we write an OK to the response writer. Dot write header http dot status OK. Ooh. And then now let's see, equals to server dot new cache server, and then we http hand of func set, we'll have cs dot set handler, and the http dot handle func slash get will be cs dot get handler, and then we error equals to http dot listen and serve. We'll serve this on port 8089. Now if there is an error, if error not equal to nil, let's log dot fatal error, and I think go run main.go should work now. Yeah, now it works. So let's go to Insomnia and see if we can set 8089 status. Okay, and then let's see if we can do a get. Yeah, so this was the value we set, Mahinya 0002, and it's the value we get. So this works fine. Let's check our console. So nothing happens here. So in the next video on this series, we are going to include proper logging, and then we will implement the cache evictions, and then after that we implement replication, and then we demo the whole project and see how it goes. Thanks for watching, and if you found this useful, share with a friend, give a thumbs up, and let us grow together writing tutorials that you can actually transfer and use in your production applications. After all this, we'll write tests if time allows and all that. Thank you, and have a good time.